There's many different pieces to it. So this one function is actually three-parted. We have a boundary here at -2. We have a boundary here at -2 and +3. We have a boundary here at +3. So the first thing we're going to do is just evaluate. Simply evaluation. Alright, so if we look at the ones here, f of x, which is now 8, equals what? So x is always inside, right? Now it's at 8. So I look on the right side to see which inequality, which restriction would be true for my 8. Okay, so where would it be? Well, it'll be the last one. If I have this as 8 is greater than 3, 8 is greater than 3 is true. Okay, so I need to plug in my 8 value over here. But we don't have an x. So automatically our answer is going to be 6. Okay, so 8 is greater than 3. We would plug in the 8, but we don't have an x, so it's automatically just that number 6. Alright, next, -2. Where would -2 be true? Well, I have two -2's here. This one on the top and this one in the middle. This first one is going to be the true statement because -2 is less than or equal to -2. Or equal to makes it true. Is -2 less than -2? No, it doesn't have an or equals, so that's not true. So we're going to plug this into the first one. So it'll be 2. We're going to put our x is now -2, so parentheses -2. And then we have -1. So -4 minus 1 is -5. So our answer is -5. Alright, next one, 5. Where are we going to have x is greater than 5? Or 5 for our inequality? So it's going to be the third one. 5 is greater than 3. That is true. Once again, we can't plug in anything because we just have 6. So that's my answer. Okay? Alright, let's look at these here. -4. So where would -4 be true? The first, second, or third? So -4 would be true for the first one because -4 is less than -2. Alright, so we plug it in again. We have 2 parentheses -4 minus 1, which is -8 minus 1, which is -9. So that's our answer. Okay. 3. Where would the restriction be true if x was 3? Once again, we have 3 and 3. So which one is it? The first one or the second one? Well, it's going to be this first one right here in the middle. Because once again, we have the equal sign. So we have to plug our x in to this equation, which our x is now 3. So we have 3 squared, which is just 9. Not 3 times 2. 3 squared is 3 times 3. 3 times 3. Alright, last one. F of x equals 1. Where is it true? Right here in the middle. -2 is less than 1, which is less than or equal to 3. Basically, you have every number, -2 to 3, ones in the middle of both of those. It's true. Alright, so plug it in. X squared is now x for 1. So we have 1 squared. 1 times 1 is still 1. 1 squared is 1. Alright? Alright, so that's the easy part. Evaluation. Let's do the graphs. Okay, these are going to be our graphs. Alright, so what I like to do is look at our restrictions first. Okay? This restriction, that restriction. Okay? And I like to look at what we have for our lines. So, think about the number lines when we did in the very beginning. We're just looking at these right here. If I was doing my number line, how would I graph this out? Well, since it's less than, it'll be open. The arrow points to the left. So our arrow points to the left. Okay? So this inequality, less than or equal to, makes it solid or closed. And then less than will be open. Two numbers connected to be the line segment. Okay? The last one is going to be closed because the or equals 2. The arrow points to the right, so our arrow points to the right. So that'll help us with our graph, okay? The next thing I like to do is look at our restrictions. What number do you see keep on popping up? Well, -2 is here, 1 is here. So that means I have my boundaries at -2 and at +1. So -2 is right here. So this is not an asymptote. I'm just drawing this dotted line to help us graph, so we know not to cross that line, okay? But these are not asymptotes. So this 5 should be on the left side here. This quadratic should be in the middle. And then this linear function should be at the end on going to the right. Okay, that's what that means. Okay, so this basically is just going to be calculator skills. You just got to graph and figure out what you need to graph. So if I open up my calculator, alright, so 5, we should know this, but if you don't, you can graph it. You're going to have a horizontal line go left to right. All your y values are going to be 5, right? So over here, what I'm going to do is, I know this arrow is going over here because that's what we said in the very, very front. So it goes to the left, and once I hit that dotted line, that's where I'm going to have my open circle. So I know that this is going to come all the way out here. And once I hit that restriction of -2, I'm actually going to have it open, okay? So our line goes on forever, but we only need to graph the left side of -2. So that's what we did. All right, so then the next one, quadratic, you could do different ways. I just opened up a new document. Okay, so x squared plus 1. All right, so obviously we should have a quadratic because it's x squared. But for this one, all I want to do is graph from -2, say -2 was here, and it's closed, and then we have to go to 1, which is here. So we should only graph that little portion from here, which is closed, down here, which would be open, okay? So if I look at my table, erase that. Okay. So if I look at my table, I know my x value has to be at -2. So -2 is right here. So -2, 5. That's my first point. But we have an issue because -2, 5, we already graphed with the open circle. So what we have to do, we're going to close it. The closed dot takes priority over the open dot. So if they overlap, you need to close it, okay? So we closed it. So that's my first point. Then I have to do the rest all the way to +1 because that's what my restriction is, okay? So -1, 2. Here, 0, 1 here. And then we get to a dotted line. So we need to do our open endpoint. So what was it? 1, 2 should be open. And then I connect my points because I know it's supposed to be a parabola, so it should be curvy like a U. And that's that. And then we just have one more to do. So open a new document. Gonna graph -2x. Alright, so here it is. It's linear, negative slope, but I only need to graph from 1 going on to the left. Or I'm sorry, going on to the right. So that would look something like this value going on to here. Okay, so from here to about there, something like that. So we need to do our table, controls T. There it is, 1. I need everything that's bigger than 1. Everything that's bigger than 1. So 1, -2. So 1, -2 is right here. We said it was supposed to be close, so 1, -2 is closed. And then we just graph out the rest of the points, okay? So 2, 4 here. So it's going down 2 over 1 every time. So that's all my points. But at the end, we said we're supposed to have an arrow. So connect the dots, then draw your arrow. So that is your piecewise function. Okay, we have the 5, then we have our quadratic, then we have our linear line. So, is this continuous or discontinuous? Well, this is discontinuous. Why? Because in order to draw this whole entire function out, I'm fine here, here. Oh, I have a gap. So literally when I have to pick up my pencil to move down here, it becomes discontinuous. Okay, so that's the reason why. All right, one more. All right, so once again, look at your restrictions. Okay, we have that there. What would it look like on a number line? Well, this would be open to the left, open to the left. This would be closed because of my line underneath, and it would be going to the right. So open because no line, points to the left, points to the left. Right, right, closed because of the line. All right, so my boundary would be at +4. So I draw my dotted line just to show my boundaries. All right, so last one, square, or not square root, absolute value. Oops, sorry. All right, absolute value. Remember that button for absolute value is right here by the 9 in the book. Press it, and then there you have absolute value. 9 in the book. Call it our matrix button, if you will. All right, so x minus 3. All right, so we have a absolute value, which is a v. But all I need is every value less than 4. So when I look at my table, every value less than 4. So I'm going to count down on my x's. 4, 3, 2, 1. That's all I care about. All right, so 4, 1 is our first point, but we said it had to be open. So this is open. And then we just plot everything else. We have 3, 0, 2, 1, 1, 2. I mean, you could keep on going if you wanted to, but everything's just going to go in the upward motion. So connect your dots. At the end, we have our arrow, because that's what we said we would have. So again, we don't have the whole entire absolute value. We just have it from 1 to infinity going to the left. So we have a backwards check mark. All right, last part. Do it again, but with our linear function. Sorry. So -1/4 x plus 2. We have a linear function, negative slope, so we're going down. And then lastly, look at our table. The first x value we want to start with, which is 4, because that's what it has over here. So that's our first value. So we have 4, 1. 4, 1 is exactly where the open circle is, but this linear line needs to be closed, so we shall close it. And then we're just going to use the points that we have. So there's decimals here. We don't care about those. You could do that one if you want to. The next whole number is 80, so I would use 80. I don't really care about the decimals. And then past 10, our graph doesn't go past 10. So we only have 2 points, but we know that it should be going down. So connect the dots. At the end, we should have an arrow. So an arrow. All right, so that's your second piecewise function, p of x. And this is continuous. Because if I draw this from left to right, I never have to pick up my pencil.